Thank you for selecting my talk on Project Omega, Envisioning a New Cataloguing System for the National Archives. My name is Faith Lawrence, and I am a Data Analyst for the Catalogue, Taxonomy and Data Department. If this presentation were part of a normal catalogue day, then I would assume you were here because you were familiar with the National Archives and our work, or had taken a really wrong turn looking for the place with the flowers. But for anyone who is joining us for the first time, please allow me a brief bit of background. The National Archives is the UK government's archives and official publisher. As such, our collections reflect 1,000-odd years of British and world history. Being the record of government, our records include a lot of death, taxes and random bureaucracy. But, being the record of government, there is also plenty of sex, scandal and intrigue, resulting in a diverse collection that even we at Kew are still exploring the depths of. The formats are diverse as well. Even on the physical side, as well as paper files and rolls of parchment, we have maps, photographs, artworks and fabric samples, wax seals, doors, and even the odd mummified rodent. And increasingly, we are now acquiring born digital objects, including emails, databases, and archived websites. Last year, TNA launched our Archives for Everyone initiative, with the goal of making the archive more inclusive, entrepreneurial, and disruptive. This talk will mostly focus on the inclusive and disruptive aspects, as I discuss the current and future plans for the catalogue. For many people, especially this year as on-site access is limited, their first introduction to the archive is via our online catalogue, Discovery. This is the public face of the catalogue, with records related to over 25 million assets, both physical and digital, and an additional 11 million records related to items held at other archives around the country. The public catalogue is underpinned by the internal cataloguing system and editorial process. This process is how new records are added and corrections and other improvements are made. However, behind the scenes, it is made up of multiple overlapping databases, resulting in multiple potential points of failure due to the complex interactions between the different data stores and, in some cases, the lack of a clearly definitive version. Further, the editorial application has reached what is known as end of life. That is, it is no longer supported. And as a result of the age of the technology, it is not possible to make any changes to improve usability or make other quality of life improvements. With this in mind, the challenge facing us is to create a new back-end catalogue system. As we are going behind the scenes of designing this potential system, I'm going to get a little bit technical, but I will do my best to explain as I go along to try and keep everything clear for those who are not from a technical background, which is probably the majority of my listeners. With the idea of the disruptive archive in mind, we want to take the opportunity to not just replace the existing system, but to take advantage of recent technology improvements to create something much better. When I say better, this has two parts. Firstly, better for the archivists and editors who are updating and maintaining the catalogue to make the workflow easier, more user-friendly and more efficient. And secondly, and indirectly, making it better for the public users by making it easier to search, share and expose the data in the catalogue and provide better support for the new front-end system that is also being developed. The project to investigate and create the new cataloguing system is Project Omega, which started last year under the ownership of Jone Garmendia, head of the Catalogue, Taxonomy and Data Department. Together with myself, we brought on board our wonderful consultant Adam Retter to develop a working proof of concept for a new system for managing catalogue data. So when I say we did something, all credit actually goes to Adam. One of the most exciting things about Project Omega is that we had the opportunity to start from a completely blank slate rather than trying to build on an existing system. So some of the first questions that we had to ask was what type of technology would be the best fit for what we and our data needed. For the technology itself, there were three obvious avenues we could go down. Relational databases are what most people think of when somebody says database. They work by having a series of tables, like spreadsheets, which are linked together and can be connected and queried as needed. As the technology has been around for so long, it has been refined and tweaked so it is both stable, robust, and reliable. However, the way the data is stored doesn't really match up with the structures that we get in archival data. So, what are the other options? XML is a way of marking up data with conceptual annotations so that it can be read by both humans and computers. The data is stored in a hierarchical format, and there exist internationally recognized standards to encode archival data, such as EAD, the Encoded Archival Description Language. A native XML database is designed specifically to work with this type of hierarchical data and to take advantage of the structural links encoded within that data. EAD is not only being used as part of the current upload transformation process, but is a well-known standard for archival data sharing, so going in this direction would allow us to take advantage of both these things. It is also worth noting that an XML database system is being used to great effect by the legislation.gov team, showing that this could be a potentially beneficial way forward. The final option would be to go in the direction of a graph database, closely associated with the idea of linked data, which has grown in popularity over the last few years as it has moved from academia to enterprise-level implementation. Graph databases have some similarities to XML databases in that they encode both the data and the relationships between the data. While an XML database is constrained by a defined hierarchical structure, graph databases have a freer network structure, although to get the most out of a system, a data model, schema, or ontology will define how the different types of data fit together. You may be asking why this matters. It is true that how we store the data doesn't determine what we can do with the data once we've got it out of that storage. We can always transform the data, or the parts of the data that we care about at a given moment, into different formats and apply other tools and techniques to it. But each of these systems have different strengths, weaknesses, and efficiencies. So if we want our new system to be as streamlined and efficient as possible, then it helps if the software we select works with our needs rather than being repurposed to support them. The other fundamental thing that we need to decide before we can move forward is what the underlying data model should be. I mentioned data models in passing before. These models are an abstract description of how concepts in a particular subject fit together. You are listening to and watching this presentation, at least I hope you are. It is made up of a series of slides, which come before and after each other in a defined sequence, and the narration, which exists in conjunction to those slides. All of these relate to a timeline of events, slides changing, the contents of the slides appearing, the sound recording starting, etc. These are the concepts which relate to the abstract idea of a presentation video, and we could define a model which describes what each of these concepts were and how they related to each other. It is important to remember that data models are approximations, so they're never completely right, but they give us a good starting point from which we can communicate. I view the world like this. Explain and make predictions. If I know this thing and the model says it does that, then I should be able to transform it in this way to get my answer. Or to compare viewpoints. Is my model of a topic the same as your model? To decide on what model best suited our needs, we selected 11 existing data models that were either already used within TNA or relevant to archival or related theory. To evaluate them, we created a series of 11 functional requirements, that is, 11 requirements that the data model needed to support, and 23 test cases, 12 related to born physical records, 10 related to born digital records, and one which was equally applicable to both. Rather than go through the details of each test, which you can look up if you're interested. I'll give a link in the next slide. I wanted to pull out a few themes that we noticed as part of the evaluation. Thinking back on the different technologies I mentioned earlier, the older standards all used a hierarchical model, as you would use in an XML database, while the more recent standards all adopted a graph model. Further, one of the improvements that we hope to make in the new catalogue system is a better description of the provenance of and changes to records over time, which we can't currently do. The graph-based models that we evaluated all provided ways of doing this. They also allowed both hierarchical and ad hoc arrangements of records, so it would support both the traditional orderings, the divs, series, items, etc. that we all know and love, and would also allow other arrangements and collections, especially important with born digital records. Also important for born digital records, almost all of the standards supported the separation of the concept of a record from its realization, allowing multiple versions to be connected to a single concept. For example, a record may have the original version, the redacted version, the digitized redacted version, the digitized redacted version in a different format. I could go on. It was also noted that there were some clear conceptual differences between the standards that were influenced by library theory and those that came out of archival theory. This is probably to be expected, but interesting and harks back to what I said earlier about data models as a way of comparing different viewpoints. Comparing the different standards, there wasn't one outright winner, but we were able to narrow our options down to 3 likely candidates. BibFrame Lite with the archives expansion, the Records in Context RIC ontology created by the International Council on Archives, and Matterhorn RDF, which is also an expression of the RIC conceptual model, but using existing standards and vocabularies. Taking into consideration the guiding principles of disruption and inclusivity that we mentioned earlier, we selected Matterhorn RDF as the model we wanted to take forward. For anyone who wants to read the full report of the model evaluation, the link is at the bottom of the slide. Having selected our data model, we can use this to guide us in selecting the technological solution that will work the most efficiently with it. Matterhorn RDF uses a graph model, so it is logical to combine it with a graph database. This investigation changed our thinking from the start of the project, since initially we had been thinking that the XML solution would be the way forward. But combining a graph model and a graph database allows us to store the catalogue data in a format that is designed for archival data. There are many graph databases that we could choose from. Following the current trend of cloud solutions, we will explore the possibility of using Amazon Neptune in the first instance, as it comes with the AWS platform. However, having the data defined by the data model, we can easily transfer it to a different graph database if Neptune doesn't meet our needs. So, where are we now? Having selected the data model, we applied it to samples of records from our catalogue, starting with item-level descriptions, as they have the most complex data structures surrounding them. A pipeline was developed that extracted data from the current database and transformed it into the new data format. In keeping with the ethos of open development, links to this pipeline are available on the Project Omega webpage, which I will give details of at the end, as is a report on the application of the model to our data with examples. Additionally, we've run a small number of surveys among staff who use the current editorial system regularly to help us prioritize the development of a user interface through which the new catalogue system will be managed and the editorial process supported. For many people, the idea of graph databases are intrinsically connected to the idea of linked data, which many of you may have heard of, especially if you were paying attention earlier in my talk. The graph is a network, a linkage of data. It offers the possibility not only to link our data together, but to link our data to other data held outside TNA, both in the cultural sector, museums especially are making increasingly use of linked data, but also to other resources, such as authority lists of people, places, and events, which may have additional information which would be helpful to our users. and to give others the opportunity to link their resources back to our data as an authoritative source of information. To do this, we need unique and persistent identifiers. That is, a name or label for everything that we want to refer to in our graph. Don't worry, we won't be getting rid of any existing ways of referring to a record in our archive. They will still be part of the data connected to the record. But we will add an additional identifier that the computer system will be able to use to be able to unambiguously reference a given record or other item of information. We published a set of articles proposing how we would generate these identifiers and what they would look like, and set up an internal working group to discuss and extend the proposal beyond catalogue records. We've since revised our initial suggestions, and a new report should be released soon, probably in the new year. So, we know where we are, but where do we go next? We are currently recruiting 2 contractors to work on the next stage of Project Omega, which we hope will start in either December or January, depending on availability. The focus of this stage of the project will be to completing the data extraction, both to test and verify the model that we have developed, and to test the suitability of AWS Neptune, and to start developing the user interface and editorial system that will be used by our archivists and editors to expand and manage the catalogue. This will be undertaken in close consultation with the staff who will work on the system to ensure that the design supports their needs and work processes. I hope I've been able to give you a glimpse behind the scenes at some of the complexities that go into designing a new cataloguing system, and an understanding of why we have made the choices that we have as we look to a future system which will, we hope, improve the lives of the members of staff that will be working with it, and, through new archival-led data structures and a back-end system, offer more opportunities to use, share, search, and connect with our catalogue data, which will in turn lead to improved services for the public. The link at the bottom of the slide is the Project Omega website, which contains ongoing details of the project and links to the reports and resources that I have mentioned. Thank you for listening to my talk. If you have any questions about Project Omega and the future direction of the catalogue, you can contact us at catalogueprojects@nationalarchives.gov.uk. Again, thank you for listening and have a great day.